All right, here are just some problems from the R2 R4 quiz to go over. So problem 4, I have 2 examples from problem 4. What they're asking is that you note what is excluded from the domain. So when you are thinking about domain, what I want you to think of is all x values that you could put into this equation, and you'll get an answer that is real. One second. I dropped my calculator. So when we think of, like, if it was just something without a fraction, 2 plus x, there's nothing that it couldn't be, right? All right, I said 2 plus x. I want to share my screen with you, show you in Desmos what 2 plus x looks like. Looks like this, okay? Just the expression x looks like this. All right, we can put expressions into a graphing calculator and it will show up as 2 points, an x and a y point on the graph, okay? If we have x squared over x squared plus 25, that graph is going to look like this. So when x is negative 20, for example, y is going to be 0.941, okay? In all 3 of these examples, the line goes on forever. It never disappears, it never stops. There aren't any holes in the graph, okay? But let's look at this example. X squared over x squared minus 81. Do you see what the graph does? There are points on this graph that don't ever, the line is never going to touch a number. If you zoom in, zoom in, zoom in, that number is a negative 9. So your graph is never going to touch the number negative 9 or the number positive 9, okay? The square root of x, there is no negative x value. The graph stops at 0. You cannot have a negative number under that radical, so the graph doesn't even begin until x is not a negative number. If you have something more complex under the radical, then they'll take that into account. This graph won't even start until you get to the number 10, because if you look, 10 minus 10 is 0. All right, you don't need to totally understand this. We will talk about this a lot later, but I want you to notice where the graph doesn't exist, because that's what we're talking about when we're talking about the domain. Where does the graph not exist? And you're welcome to use Desmos on all the exams. So if you have a question, you're welcome to put that into the into your Desmos. And so we have 2 examples. These are our 2 examples. Our first example, the graph goes on forever. The second example, the graph doesn't exist at negative 9 and positive 9. I want you to remember that, okay, as we go through this. So that's what they're asking about for domain. This is every number. There's nothing on the graph that doesn't exist when we put in 2 plus x on our graph. So that's the difference. However, the rule, if you have a fraction, is the number on the denominator of the fraction cannot be 0. Okay, so I cannot have a number squared plus 25 equals 0. That's a problem. To find out if there is any x value that will give me a 0 in my denominator, what I do is I take that denominator. It does not matter what's up here. This can be 0, doesn't matter. You take only your denominator and set it equal to 0, okay? So I'm going to say x squared plus 25 is 0. What's my first step? I'm going to subtract 25 because I'm just solving for x. Anything I do to one side, I have to do to the other. So that is x squared equals 0 minus 25 is a negative 25. Okay. Now what do I do? So the opposite of adding 25 is to subtract 25. The opposite of x squared is to take the square root of x. Anything I do to this side, I have to do to this side. So now I'm going to take the square root of negative 25. When you take the square root, this is just something to remember. It's okay if you understand it. It's okay if you don't understand it. Just remember it. Just always do it, okay? When we're solving for an x squared, you take the square root, and on this side, we have to include a positive and a negative answer, okay? Think about this. If it was x squared is 4, right? I'm solving for x. So if I take the square root of x squared and the square root of 4, the square root of x squared becomes x, and the square root of 4 becomes 2, right? X is 2. 2 squared, if I put that back, 2 squared is 4, that is true, but there's another answer that's also true. -2 squared is also 4. There are two different answers that are both true that will both give me x squared equals 4. That's why we have the plus and the minus. If we have x squared equals positive and negative square root of 4, then we have x equals -2 and x equals 2. We've included both of our answers, so that's why we have the plus and the minus. All right, moving on. Sorry. So now we have the square root of x squared equals plus or minus the square root of -25. But what's the square root of -25? It's a not real answer. At this point, until later in the semester, that just means there's no answer. So there is no positive square root of -25. There is no negative square root of -25. So we just say x can be anything. And if you think about what we originally had, is there a number I can put here that I square it and add to 25 and it will equal 0? No. There's no number, even if you have -5, right? -5 squared, it's going to give you a positive. A positive plus a positive is going to remain a positive. So this number from this equation does not have any part of the graph that just doesn't exist, okay? Remember, a part of the graph that doesn't exist is something like this. This graph doesn't begin until x is 0. This graph is everywhere. It doesn't matter where it is on the y, if it's going up, above, if it's way down here, it exists, okay? This one doesn't exist everywhere, this one doesn't exist everywhere, this one doesn't exist everywhere. But this one's okay. There's no number I can put in for x that will make my denominator equal to 0. Let's just go straight down to this one now. X divided by x squared minus 81. Remember that graph looked like this, right? That means there are numbers here, there's a number here, and there's a point here, a point or a number, where the graph will not exist. So same thing though. This is your numerator. This is your denominator. You do not want the denominator to equal 0. This cannot equal 0. So what you're going to do is you're going to take it down here and you're just going to set it equal to 0. X squared minus 81 is 0. Good? This looks very blurry, doesn't it? Slightly better, maybe it's my eyes. All right, same thing we did up here. Here we were adding 25, so we're going to subtract 25. Here we're subtracting 81, so we're going to add 81. Do you see how there's already a difference between whether that was a negative or a positive? There's a difference, right? So now those cancel. I'm left with x squared equals a positive 81. Same exact thing though. I need x squared to just be x, so I'm going to take the square root. The square root cancels the square. But like we saw with that 4, you have to include a positive and a negative answer for that, okay? The square root gets rid of the square. We're left with x equals, now put it in your calculator. The square root of 81 is 9. So x is that plus or that minus, and then that 81 is 9. So x is -9, and x is 9. If we look back at that graph, that is where our graph disappears. Right at -9 is where it starts going up and down forever, never touches -9. At +9, up and down forever, it never touches +9. Okay, so those are our answers. X cannot be -9 and x cannot be 9. Put those back into your equation. -9 squared minus 81 is 0, right? That's a problem. +9 minus 81 squared minus 81 is 0. That's a problem. So you've confirmed that you need to exclude these two numbers in the domain. And again, use Desmos if you would like on exam day, okay? It can tell you whether it's none, right? So this is none, all the numbers are okay, all real numbers, nothing needs to be excluded. Nothing needs to be excluded is not the same as 0, right? Just nothing needs to be excluded. This, we have to exclude -9, exclude +9. But your graph will tell you if you graph it in Desmos. All right, moving on to distributing. Here we have a monomial, and we're going to distribute it to this binomial. So we're going to take -6 x squared, and we're going to multiply it by 4x to the 4th. And then we're going to multiply -6x squared times 6. Okay? Not really good. Good? So we took this, and you're just going to multiply the numbers, okay? Just look at the numbers. A -6 and a 4 become a -24. X squared and x to the 4th, you're just adding those. So we have a 2 plus a 4 become a 6. That's your first term. You're done. All right, you got the negative times the positive. So you got a negative times a positive is a negative. 6 times 4 is 24. X squared times x to the 4th is x to the 6th. All right, let's look at this again. Now we have the numbers, -6 and 6 becomes -36. Okay, and then the variable is just x squared. You're done. Okay, see, I look at the numbers, combine them. I look at the exponents, combine them. Make sure you have the right sign. Negative times a positive is a negative. Negative times a positive is a negative. Same thing down here. Here we have a -3 times a +2. And then we have an x to the 4th times x to the 3rd. A negative times a positive is a negative, so it's going to be a -6. Remember, when you're multiplying exponents, you keep the base and add them. 4 and 3 is 7. Good. A confusing part can be saying, all right, I'm multiplying a -3x to the 4th times a +7. Should I put a plus right here or a minus? I always just put a plus, and then I write the negative and the positive sign with the number, okay? Because you're combining a negative, which is the same as subtracting, but I'm just less likely to get confused if I just say plus and then I write the number with the sign times the number with the sign. So that's what I do. And then it only has an x to the 4th, so we're just going to multiply it by x to the 4th. -3 times a +7, a negative times a positive is going to be a negative, right? So that's a -21 x to the 4th. So you can say plus -21 x to the 4th, or you can just say minus 21 x to the 4th. All right, the 6s. I think I'm going to go to a different piece of paper. So this is just more of that same thing. It just takes longer because it's more complex, right? All right, so here we have a 5. We're going to distribute the 5 to the x to the 3rd. So that just becomes 5x to the 3rd. And I encourage you to just go real slow. Take that 5, multiply it with the x squared. And again, I use a plus. 5x squared. Okay. Then take that 5, multiply it by -6. So plus 5 times -6. Those are my first 3 terms. And then we're going to have 2 more terms. You can go back and finish those if you want, or you can go to the 4. So it's a -4. So I'm going to keep saying plus. Plus -4 times a +2 times an x to the 3rd. unfold this because of course I'm out of space. Negative 4 times a negative 2x to the fourth. So plus negative 4 times negative 2x squared. Good? Okay. Another thing that I just thought of up here is if you have negative 6x squared, so I said multiply the 6 and the 4 and get a negative 24, then when you're multiplying the x's, it's not that this is still an negative x squared. The negative went with the 6, so the negative's already accounted for. You only have to count the negative once when you're multiplying or dividing, okay? So the negative 4, if it was a negative 4x, you wouldn't say negative 4 times positive 2, negative x times positive x. Just count it once. Anyway, doesn't matter. 5x to the third. 5 times x squared is just a positive 5x squared. 5 times a negative 6 is going to be a negative 30, right? Negative 4 times 2 is going to be a negative 8x cubed plus 4 times negative 4 times negative 2 is going to be another positive 8x squared. Now, what you want to do is combine like terms. Like terms means it has the same exponent raised to the same power. So x to the third and x to the third means I'm going to combine a positive 5 and a negative 8. Positive 5 and negative 8 just become negative 3x cubed. Then we've got the exponent, or the variable x raised to the second power, x to the second power. So that means a positive 5 plus 8, which means plus 13x squared, and then minus 30. All right, something else I can show you in Desmos is if you take that original expression and make sure you write it perfectly into Desmos, and you take your answer and write it perfectly into Desmos, they should, so you'll get a crazy graph of some sort, but they should overlap. Okay, that answer is the same as that answer because the line is the same as that line. So it's a way to check your answer. All right, our next example for number 6 is distributing a 3 and distributing a negative 2. So 3 times x cubed is 3x cubed, or 3x to the third. 3 times an x squared, they're both positive, is a positive 3x squared. And then 3 times a negative 6, a positive times a negative is going to be a negative. So we're going to say minus 6 times 3 is 18. And then move on to the negative 2. So negative 2 times a positive 3 is going to be a negative 6. Negative 2 times a negative 2. So negative times a negative is a positive. So that's a plus 4x squared. Good. Now we're going to add like terms. X cubed and x cubed. Make sure you see that it's a negative here and a positive here. So 3 minus 6, right? X cubed becomes negative 3x cubed. Then we can combine the x squared and the x squared. So that's a positive 4 and a positive 3. So I'm going to put a plus. 4 and 3 x cubed is a 7x cubed minus 18. Again, if we look at Desmos, here is our answer, here's the original equation, and the graphs are on top of each other. Here we have a 5 we're going to distribute. So 5x cubed becomes 5x cubed. 5 times x squared is just 5x squared. 5 times a negative 2 is a negative 10. Negative 3 times a 2 is a negative 6. Negative 3 times a negative 2 is going to be a positive 6 x squared. Good. So we have x cubed, negative 6x cubed. So we have 5 minus 6 x cubed, the negative x cubed, right? Then we've got x squared and x squared. So positive 6x squared and positive 5x squared. (11x squared), and then minus 10. And again, you can check your answer. So we can graph our original, graph our answer, make sure they are on the same line. All right, I hope that helps you with the R2, R4 quiz.